Right. Good evening, Shane. Nice to see you again, mate.
Yeah, nice to see you back again.
Yeah. Well, I turned up. It's good to see you turned up.
Yep.
Must have done something right.
Yeah, exactly.
Keep you coming back.
Yeah.
Beauty. It's good. All right, mate. So, welcome back. Big letters there. Yesterday's session, we discussed planning a routine task or activity. What is the keynote that you took away from yesterday's session? Just to see if I made an impact, if it sunk in a little bit. What's something that you took away from it?
Today it helped me a lot. Exactly what you said. I got straight into work, had a bunch of jobs ready to go, and I just got all my tools ready before I started.
Yep.
Made sure, had a look at, see if I was on drill press all day, made sure that I didn't have gloves, or if I wasn't, made sure I had my gloves.
Yep.
And it made me have a quicker flow through work.
Yep. You're way more conscious of it.
I was like, oh, where's my ruler? And I was just like, dry my leg.
You find it's going to be a way more effective tool to have on your tool belt moving forward?
Oh yeah, 100%.
Being able to have that mindset of plan and preparation.
As I said, it helped me heaps today. Just coasted through today without having to
fluff around looking for tools.
Fluff around waiting and be like, oh, I've got to start my job down at this end of the workshop. My rule's already on the other end.
Perfect. It's good, mate. I'm glad to hear that. Hopefully it can stay with you. If you can, implement that every day for a little while, you'll find you won't even think of it anymore. It'll just become a natural skill set that you've just armed yourself with, and you'll take that with you moving forward.
Yep.
Do you feel planning ahead for today's session and planning to undertake routine tasks has been effective and beneficial? Yep. We've just answered that one.
Yep.
I'm glad to hear it. It's really good.
Yep.
I'm happy, mate. Today's session. Do you remember when we talked yesterday and we went over a bit of a debrief of the whole 3 sessions, what today's was going to be about?
Yeah, it was interpret technical drawings, wasn't it?
It's good. You're listening. Good boy. No, you're right. Like you said, today's session is about interpreting technical drawings. Do you have much experience with technical drawings in this field? Maybe you're saying you're a second-year apprentice, but you'd come across a few drawings?
Come across a few, but usually I'm with a tradesman and they will help me through it.
Yep.
And I'm getting to the point now to where the boss wants me to just do it by myself. Don't have to pull tradesmen aside to help me through it.
Yep.
Now he's just like, I want you to do your own thing.
Yep.
Stop budging them, and so then he can get me into a bigger role.
Beautiful.
Later on.
It's good. And he has a bit of trust in your skill set. That's good to see. Alrighty, so moving to the start of today's session, I'd just like to do an acknowledgement of country. So I'd like to acknowledge the Biripi people, the traditional owners of the land in which I present to you from today. I'd like to pay my respects to the elders past, present and emerging. So again, a bit of safety measures that we have to go through before the session. Yesterday I went through it a little bit. Today I'll get you to go over it a little bit. So while we are doing 3 sessions in a minimal risk environment, then we're not doing much hand tool work and machine work, mechanical work. There's none of that going on in this session. We still are in a metal engineering environment.
Yep.
So we do have to be careful. So therefore we'll do a quick WHS debrief together. So hit me, Shane. What are some things we need to factor in?
We need to factor in to make sure that the environment that we're in is safe.
Yep.
Obviously, we got the fire exit in the exact same place we were last time.
Yep.
And it's not obstructed.
Yep.
We have our cotton drill shirt, cotton drill pants, steel cap boots, safety glasses.
Yep.
And then if need be, we have our gloves on the camera.
Ready to go.
What else?
Pretty much it, mate, for what we're going to be doing over the next 2 days. It's pretty much it. You've nailed it. We do have a fire extinguisher over there behind you.
Yes.
Bit of luck, we don't have a fire, but we know where it is in case we do. Beauty. All right, I'll tick through these. Oh yeah, in a well ventilated area as well.
Yeah, the windows are open. We have a ventilator just in case.
Yep. Beautiful. All right, so session 2, MEM 09002B. That's interpret technical drawings. All right, when I say the terminology interpret technical drawing, what do you think that might entail in our metal engineering environment and sector?
Like interpret a technical drawing, I'm guessing means being able to read and understand a technical drawing, so then you can basically read that and change it, turn it into a bit of material, and then actually fabricate that into an actual piece.
Yep, that's good. It's basically, yeah, it goes. Well, I think this next slide does have there is a short video here, so I'll click this. It's only 6 minutes long.
Just one thing, from yesterday when we went and got the tools, I did remember one tool this afternoon. I got a 400mm combination square.
Oh,
so
right.
then we do further than 300, then it still is going to be square. And then you go a longer line, it's
Beautiful.
square 100%.
Awesome, mate. I did see that sitting over there on the toolbox. I remember it wasn't there yesterday afternoon, so you've good. You went home and thought about it.
Yeah.
Good on you. All right, so interpret technical drawing. We've got the short video here for 6 minutes. I'll just get you to watch this one, mate.
So easy.
Bear with me here while this loads up.
When you get your next big idea, Grammarly's tone suggestions can help pitch it with confidence to get your...
In this easy end video lecture, we will learn what is engineering drawing, drawing instruments and its uses, and lines and types of lines. First, we will see what is engineering drawing. Engineering drawing is a type of technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. More than drawing pictures, it is also a language, a graphical language that communicates ideas and information from one mind to another. Most important, it communicates all needed information from the engineer who designed the part to the worker who will make it. Application of engineering drawing is used in ships, manufacturing, aerodynamics of automobiles, constructions, etc. Let us see different drawing instruments used in engineering drawing. In this we have a drawing board, drawing paper, pens, clips or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass and eraser. Hey, it's time to concentrate now. Now let us describe each and every instrument. Drawing board is rectangular in shape and is made of wood about 25 mm thick.
So we don't actually have drawing boards in our factory, but we do have level benches.
Mm-hmm.
The surface of the board should be smooth and it is used to keep the drawing paper. There is a working edge at the side of the drawing board. While selecting a drawing paper, we have to be sure that the size of the paper is smaller than the drawing board. To hold this drawing paper, we use pins or clips or adhesive tapes. Pencils are basically used to draw. The accuracy and appearance of a drawing depends on the quality of the pencils used. The grade of pencils, H, 2H and HB are mostly used. Next is the T-square. It is made of two parts, the stock and the blade, which are joined together at right angles by means of screws and pins. T-square is fitted at the side of the drawing board and it slides along the edge of the board and is used to draw horizontal straight lines. Set square is triangular in shape with one of the angles as right angle. Two forms of the set square are generally used. One having angles 45, 45 and 90 degree and the other is 30, 60, 90. Set square is a combination with T-square is used to draw lines at an angle. A scale is used to draw lines of specific length. Protractor is flat and semicircular in shape. Its circumferential edge is graduated to 1 degree divisions and is numbered at every 10 degree interval and is readable from both the ends. The protractor is used to draw or measure angles. The combination of a T-square, a set square, scales, and a protractor is a drafter. Its one end is clamped by means of a screw.
That's one tool we won't see too much in our industry.
The other end is adjustable. It has a scale which is at 90 degree and also has a protractor which
in the
can be
video,
rotated
just to
at
give
certain
an idea of what
angles.
they are used for.
This scale can be moved anywhere we want within its limits. Next is a roller scale. It has a roller in it. It is used for drawing vertical lines, horizontal lines, parallel lines, angles and circles. Next instrument is the French curve. They are made in various shapes, one of which is shown here. French curve is used for drawing curves which cannot be drawn with a compass. It is used to draw curves like ellipse, parabola, hyperbola, etc. A compass is used to draw a circle of a specific radius and an arc at a specific distance. Soft Indian rubber is widely used to erase pencil drawings. The eraser should be such that it does not spoil the surface of the paper. Next, we will see lines and types of lines. Just as in any textbook, we are taught to use the correct words for making correct sentences. Similarly, in engineering drawing, the details of various objects are drawn by different types of lines. Various types of lines are used in engineering drawing.
So this is very common with the kind of things I'm assuming you see in
Now
your
let
factory?
us see the different types of lines. First is a continuous thick line. This line is used to display outline and edges of the main drawing. Next is the continuous thin line. This line is basically used for dimension, extension, projection, leaders, hatching, etc. Next is a continuous thin freehand line. This line is used to show short break or irregular boundaries. Next is the continuous thin line with zigzags. This line is used to show long break. Next is the dashed line. This line is used to show hidden edges of the main object. Next is the chain thin line, long dash dotted. This line is used to represent the center line for circles and arcs. Next is the chain thin line with thick at the ends. This line is used to represent the location of a cutting plane. Let us take a quick review of what we've learned in this video lecture. First, we have seen that engineering drawing is a type of a technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. It is also called as graphical language and helps to communicate. Next, we have seen different drawing instruments used in engineering drawings such as drawing board, drawing paper, pins, clips or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass and eraser and their uses. Finally, we have seen different types of lines used in engineering drawing to draw an object. So this is the overview of our video lecture.
Alright, I can close that one.
Yeah, my agency was a boy. I mean, we were seeing each other for a while, but
Yeah.
their reporting was...
Got a bit of an ad going on. Alright, I think that's back where we want it. Alrighty.
So, from that short video, Shane, why are technical drawings necessary? Do you recall why they are necessary?
To see the correct dimensions for the object or piece of material that you're creating.
Yep.
Seeing the correct measurements, where the center hole is, the curves are, and usually technical drawing sometimes, depending on what you're making,
Yep.
is one-to-one.
Yep.
But if it's bigger, it's something
Yeah.
different scale.
Beautiful.
But yeah,
So basically, a technical drawing, their design and their purpose is to bridge communication between designers, people who come up with ideas, producers, people who put those ideas into practice. They're designed as a universal language to be understood by engineers, contractors, architects, builders, etc. So what that means is like the universal language. So if you are at a design firm for a house, let's just say architects, and they can be a hand-drawn architect or they can be using a CAD design program architect. They will design, they'll put it out, you've got your house, they'll extrapolate that over a floor plan, and then they'll have a universal language of symbols, measures, etc. They'll fill up the floor plan with all their sheets of paper, whether it's computer design or if it's hand-drawn, and then they can then, with that universal language of measures and symbols, etc., that can then move on to a builder. And he will know from that design, like the universal language that's been used, what all that means. So the technical drawing is a universal language which is to be understood by multiple professions to extrapolate information over a design. If that makes sense. So yeah, it gives us lengths, it gives us radiuses, angles, center holes, everything you said. Its main purpose is though, is to communicate, to bridge communications between design, production, and everyone in between. You know what I mean? If everyone's on that same page of language, like you could say, if I told you, like you in your field, for example, build a metal box, aluminium box. And if head office sent you down a picture of the box spread out onto a piece of paper, with all the measurements of all the pieces you've needed to assemble that box, you now know, rather than looking at a picture of a box, when it's flattened out like that, with the measurements in tail, and all the angles specified on the drawing, you know what you're looking at. You know how that will now form into box. Does that make sense? That's good. So that's the purpose of a technical drawing, just to bridge communication from A to B, C, D, E, like every level of communication, everyone's got the same language. All right. So this is our task today, mate. Separate talk. Yesterday, you remember we did a bit of a scenario.
Yep.
Where I talked through a scenario, you took down some dot points, and then we put it into practice. Today's task will be, I've got the paperwork here for you. I've got a technical drawing here for you, which this is going to run into tomorrow's session. This is actually what you'll be marking out on material.
Okay.
So if you want to have a bit of a look at that one real quick, just have a look at that. It's a basic entry-level fabrication base plate. So that's all it is. You can have a bit of a squeeze at that. That's not really meant to be there. I'll fix that real quick. Material, that says. It's just a few things cut off from the printer, that's all.
That's all right. Printer will do. Edge.
Oh, you can read better than I can. Good job. Edge. All right, so yeah, the printer just cut off a little bit at the bottom there, which we've just fixed.
Yep.
But if you just extrapolate that a little bit, dissect that in your brain a little bit, and see what, it's all pretty basic technical drawing. I'm not going to throw you in the deep end with technical drawings in this first task.
Okay.
So this is going to be the, if you do remember me saying yesterday, it's non-assessable, but I will have a little bit of a little quiz questionnaire here for you to do.
Yep.
Take as long as you want. You don't have to, it's not a race, you don't have to burn through it, and you're not going to break any records and get extra points. Like I said, it's not accessible. So really break down these questions.
Well, what does the finish mean?
So that the finish is of the material. So this is a machine finish. Has obviously it's cut off as well, but it's meant to say machine finish.
Okay.
And that's just the machine finish of the aluminium we'll be using.
Right, yeah.
All right, mate. So if you're happy to, in your own time, here's the questionnaire. You want to fill out, there's a name and date at the top of this.
Are there extra points if I write out my name?
If you can do that, yeah, that'd be good. I'll leave that one with you for a brief second. Like I said, it won't take you too long. Today's the 3rd of April. And then, I'm pretty sure that from memory there's 8 questions on here if you just want to get pieces side by side. Yeah.
Right.
Then we'll go over it together. If you need to have a drink, I didn't say to you before, like we talked about yesterday, have a drink. Adult learning environment, pretty comfortable around here. We can talk it out together if you want. Saves going through it all as a at the end. So what was that first question?
what kind of material is used for the base plate fabrication. So I just
Yep. And you,
structural aluminium.
where did you find that?
Down here where it says 6mm structural aluminium base plate design.
Beautiful. All right. So there you go. Down the bottom in your information data.
Mm-hmm.
Right. So you found that it was structural aluminium that we'll be using.
Yep.
Sweet. What's the second question is? Well,
the thickness of the material, which is same area, 6mm.
Yep.
Um,
You'll also see up here as well.
Yep.
It's showing you the same information, which has been
okay.
multiple areas. So
Yeah. Ratio.
what's that third question? I'm reading upside down here, so I'm relying on you.
What ratio was the technical drawing, and what does that mean?
Okay.
So
You
the
started
ratio-
to touch on it before, so this is your chance to.
the ratio is would be 2-to-1.
Yeah. So this one, 2-to-1 or 1-to-2.
2-to-1, and basically it's a bug at 2. But since it's 2-to-1, you basically half everything
Yep.
down to the size, to either fit on the piece of paper or to make
Yep.
it easy to draw.
Yep. So for example, in this one, for example, the base plate is a 200 by 200 square,
Mm-hmm.
but our paper won't allow that room.
Yep.
So we've halved all measurements. We've effectively halved every single measurement. If that was a 3-to-1 ratio, we divide everything by 3 to
Mhm.
fit the paper. That's basically its purpose is to fit the drawing, and then you put the ratio in that universal language to tell whoever's next on the food chain, whoever this drawing is going to, this is a 2-to-1 ratio, double every measurement
Mm-hmm.
on that piece of paper. It's good. It can bring a lot of people unstuck, and that's but it is, like we were saying, that universal language of ratios. It's one of the first things you look at on a job sheet is the ratio.
Alright. So those holes need to be drilled for the 4 times bolt holes in each corner. 10 mil.
Yep.
Since the scale is 1 to 2, are they doubled as well?
No. So they're actually sweet. So that's a good question you've raised. So the ratio questions is only for your length measurements. Yeah.
Okay.
So you can see here they're just telling you a 10 mil hole. So that's your question answer for number 4 for those 4 corner holes. But that was a good observation, Shane. Well done.
So the hole in the center, 20 mil.
What is the surface finish of the material? We discussed this at the start.
Machine finish.
Machine finish. And where did you find that? That was down the bottom with all that other
Next to
information?
the ratio.
Yep. Down in the job information.
Mm-hmm.
Okay.
What degrees on the edge? It's 45 degrees.
Yep, the lineage edge finish. 45-degree finish.
And what measurement are the corner holes in the edge of the base plate? 20 mil.
Yep. Beautiful. So that's factoring in the ratio. It says 10 mil, but factoring in the ratio, we effectively have doubled. So it's 20 mil from each edge.
Right here.
And that's the same thing, ratio, so it can fit on the piece of paper.
Right here.
Good job, mate. All right, so we don't have to go through that together because we kind of done it together, but you've done really good. Like I said, non-accessible. You can stop sweating bullets. You've done really well. You've asked some really good questions along the way, mate, so I'm really impressed. Righty.
Extra credits.
Extra credits, they're coming your way, mate. Now we'll do a bit of reflection. So what did you take away from today's session? Any questions you'd like to ask or further discuss in regards to technical drawings or interpretations?
Well, obviously, it's going to help me with doing my technical drawings. They're going to get, the more I progress into my actual job, the more technical they're actually going to get.
Yep.
Like my hidden lines and
Yep. Some of them can get really.
curves.
That's like I was saying. Like for this, for your, for your apprenticeship, for this module, it's basic level entry fabrication.
All my jobs at the moment are all those.
Yeah.
Makes it easy doing that, but
There's
from
more.
one of the tradesmen
yeah.
I've seen, they're looks like gibberish.
Yeah, it can be very confusing, mate. There's still the most advanced tradesmen out there. They can sometimes get given CAD drawings or technical drawings handed out in front of them, and they can sit there and look at it and go, "What is this?" So don't ever feel like in future years, if you manage to stay in this trade for a long time, don't ever let a job sheet come your way and question yourself, because they can be confusing.
Right.
Best thing to do in that situation is just communicate with whoever drew it, whoever done the drawing, whoever's passed it down to you. Seek assistance.
Always ask questions.
Yeah, just ask questions. If you're not for sure, mate, there's no harm in asking. Just seek some clarification along the way. You'd rather do that than stuff up $1 million project or a multi-$1,000 job, something like that. You know what I mean? You're not passing the buck to someone else.
Yep.
But you're just that. Always make sure. And like you said, that some of them can be very, very confusing.
Right.
And yeah, that's how you learn. These courses and stuff like that, we can only teach you so much to go out there, but you're going to learn a lot on job site as well. You're going to learn on factory, job site, wherever you end up in mining companies, wherever, but you'll forever learning. It's a good mentality to take with you. You're never going to know everything.
Right.
Alrighty, any feedback you want to give me?
Same as yesterday.
Yep.
Great. Helped me along. Helped me with all the questions, with the drawing, when I've asked questions.
Yep.
And answered everything like in a formal and easygoing manner. Not getting stressed out or telling me basically figure it out yourself.
You're good. You're a good student, mate. Some of them stress me out and we have to wrestle it out on the floor, but you're good. So
can I have that one?
yeah, you can have that tomorrow.
Alright.
Alright. Well, I appreciate your time again, mate. And tomorrow we'll be going into that drawing that you've just gone over and dissected with the questionnaire.
Okay.
We'll be extrapolating that over some 6mm aluminium. We'll be making that. We won't be actually jumping onto machines and making it, but we'll be going through a lesson of from paper to product.
Right, yeah.
And that'll be the end of your 3-day course. Once we get through that, we'll go over all that at the end of tomorrow. Everything that you've ticked off, the modules you've completed, the units you've passed off. So,
Right, yeah.
but I appreciate you coming in again today, mate.
Thank you very much.
No worries at all. And hopefully we can get you back tomorrow to finish this course off.
Sounds good.
Sounds good?
Yep.
Beauty. All right, mate. I'll see you tomorrow.
See you tomorrow.